So, guten Tag, hello everyone. Wonderful to be here. This is a really important opportunity to share with you the latest state of science, to pose one of the questions that we've never had to pose before in the scientific community. We've come to a point where we're aggregating so much pressure on planet Earth that we're forced to pose the following question: are we at risk of destabilizing the whole planet? Are we at risk of destabilizing the whole planet? Now, this originates not only from all the evidence that I'll be trying to present in a quick overview, it also has to do with the humble recognition that, in fact, there is a philosophical perspective on this, which is that we as humans are today the largest force of change on planet Earth, and we all depend on this sliver-thin layer of atmosphere, the 10-kilometer column that gives all life support for humanity on Earth. And up until very recently, we have treated this thin layer of the living biosphere, the atmosphere, the climate system, as basically something we exploit in one end, we transform into human well-being, and we waste in the other end, using the planet as a waste bin. And now is the time to reconnect our future to the planet to stand a chance for us to have a thriving, equitable future for humanity. Now, the starting point, of course, is a graph that you've all seen, which is essentially the exponential rise of pressures from global warming, but I'll be taking a much broader perspective, a planetary perspective on our future. Now, to summarize this talk has actually a deep mind shift implication for how we guide our own lives into the future. And what I'll be trying to present to you is the unequivocal evidence with very low scientific uncertainty that it's only in the last 50 years that we have changed conditions on Earth as they've been over the past 10,000 years when we the last ice age. So in only 50 years, we've changed conditions on Earth as they've been for the last 10,000 years. Now, that is with a very low degree of uncertainty, and it's a drama in itself. But an even larger drama, and the big mind shift, is that what happens over the coming 50 years, with a high degree of likelihood, will determine the outcome for the coming 10,000 years. Now, I'm not so sure about the age of you on average, but I must confess, I'll raise my hand, I give testimony here today that I'm part of the culprits. I've been part of this journey over the last 50 years. And if I can keep my health up, I hope to be part of a significant portion of the coming decades into this journey. This means that we are on a knife's edge. It is us in this generation who are now responsible. It is our generation to be responsible for the transformations to give all future generations on Earth a chance to thrive on planet Earth. We caused it, we are to solve it. And that is what science today shows. That is why there's such a tremendous uprising, not only in the scientific community, but also wider of stakeholders across the world, recognizing that we reached a saturation point, but also a turbulence point in terms of need for change. Now, this change is generally expressed only in this curve, which is a really important one. This is the hockey stick of observations of temperature rise on Earth. As you see here, it is the last 4 years now clearly concluded to be the warmest years on record since we started observations since the Industrial Revolution. We have raised temperatures with 1 degree Celsius, actually 1.1 degrees Celsius, since the pre-industrial times in the late 19th century. And the key message to me is not just a 1 degree Celsius warming, but it is that we've reached the warmest temperature on Earth since the last ice age. We're bumping the biophysical ceiling of the maximum temperature on Earth since we left the last ice age. This is the reality. we're now at a point of a juncture of change. But it's not only about climate change. Yesterday, the Intergovernmental Panel on Biodiversity and Ecosystem Services, the sister of the IPCC, the United Nations Scientific Intergovernmental Panel on Climate Change, released its second global assessment, concluding unequivocally that we've reached the 6th mass extinction of species on Earth. The first mass extinction caused by another species, us. One of these 6, by the way, was the loss of dinosaurs some 60 million years ago. We are at risk of now losing species so fast that we cannot exclude having collapse of ecosystems and undermining fundamental functions in our life support systems, such as producing food. Now, this has to be connected with the fact that at 1 degree Celsius warming, we're starting to see something that we have started to recognize, but now is happening at a level where we can start talking of invoices being sent back from Mother Earth into the economy at a scale we haven't seen before. Actually, I will stipulate as an hypothesis that 2018 may go down in history as the first year ever that Mother Earth started sending invoices back across the whole planet. And it started off with the heat waves in Canada, with the record temperatures measured in Africa, 51.2 degrees Celsius warming, the warmest temperature on Earth, the forest fires in California, which were passed twice with devastating social and economic costs, the Hurricane Michael, which was amplified, very likely, by global warming. We had tremendous death tolls with the floodings in the Philippines, the floodings in Kerala and South India. We had the heat waves and floods in Japan, killing more than 200 people. We then had the tremendous spectrum of minus 50 degrees Celsius in Chicago just 2 months ago and plus 50 degrees in Queensland. And then we have the latest, the cyclones hitting Mozambique and Zimbabwe, Idai, with a tremendous social cost never observed before at this level. We're starting to see an uncomfortable frequency of extreme events hitting at 1 degree Celsius warming. Now this is sinking in. It's clearly sinking in. We have the Pew Institute that quite recently released a report showing once again, this covers 29 countries in the world, showing once again that roughly 60 to 70% of populations across the world are really concerned about climate change and wants climate action. This is supported also by Yale University, it's supported by opinion polls in Europe, showing that, interestingly, below the kind of vibrations of different signals from media, underlying it, citizens are really concerned. I would even argue that this is so well anchored today among particularly younger generations that what we see in terms of the youth movement and the rising of school kids with the Fridays for the Future, where I would argue that Germany is really the ground zero in the world. I mean, no place on the planet are so many youth gathering as in Berlin on the Fridays for the Future, which is a signal that something is really happening in the world and that this is not a coincidence. It is an accumulation over a decade of recognizing increasingly that we are posing risks on planet Earth. This is also something that we're now seeing in business. You've certainly seen the World Economic Forum and its annual Global Risk Report. They interview over 2,000 business leaders around the world, and on the x-axis here you have the likelihood of disasters impacting the economy, and on the y-axis is the impact risk on business and economy, and up on the right-hand corner we have, the high impact, high likelihood impacts on the economy. And if you look carefully, business leaders assess that climate change, biodiversity crisis, our unwillingness to really deal with climate change are the biggest threats to the economy today. So this is the reality where we are, and that is a shaking world where now we're starting to see science connecting with insights and willingness to change. Now, how have we come to this? Well, I would argue that the most important message of science was when we, for a few years ago, were able to welcome humanity to the Anthropocene. Anthros for us humans, anthros from the Greek, we've now turned into our own geological epoch. We have become the dominant driver of change on Earth. We surpass in amplitude and frequency what the natural variability has taken us through the billions of years through volcanic eruptions, earthquakes, and our change in position to the sun. All this still occurs, but we have now dominating and become a bigger force. Now, is this suggestion, which I would argue is the most important message we have from science to humanity, based on models or hypotheses? No, it is based on observations. It's based on the hockey sticks you see on this graph. Published for the first time in 2007, updated since then. Each x-axis here is from 1750 until today. They show parameters like carbon dioxide release, deforestation, acidification, eutrophication, land degradation, any parameter you may wish to pick that matters for us as humans show the same pattern. Very limited change, incremental change up until the mid-1950s. And then you see this break point and the massive exponential rise of pressure from the mid-1950s. This is 10 years after the Second World War. We're 3 billion people on Earth, and it seems like that's the point where we put on the high gear of the industrial metabolism of the modern, globalized world as we know it. And off we go in this exponential rise, and we reach a point, not perhaps more than 15, 20 years ago, when we start seeing the signs of saturation, of collapse of ecosystems, of passing 350 ppm in carbon dioxide concentrations, accelerated ice melt, collapse of coral reefs, eutrophication of lake systems, vast scales of land degradation. The Earth system seems to now be at a point where it doesn't have the resilience or capacity to take more unsustainable pressure from humanity. So welcome to the Anthropocene is insight number one. Insight number two is what makes me most nervous. Because if we're putting all this pressure on Earth, the question is, what are we leaving? What do we depend on? What state of the planet do we depend on for our human well-being as 7.6, soon to be 10 billion people on Earth? Well, that is the drama. It's so dramatic that I even put it as a question. Are we leaving the Garden of Eden? Do we have scientific evidence of what is the precious, desired state of the planet? I will argue that unequivocally the answer is yes. And I'll just give you one piece of evidence, and I hope I convince you on this, which is data from Greenland. This is the ice core from Greenland. On the x-axis, you have the last 100,000 years. It's, by the way, a very good choice of time because we've been modern humans on Earth roughly 80,000 years. So we have, during this whole period, had the same ability for our intellectual and physical development of civil societies as we know it. Now, on the y-axis here is temperature variability, and as you can see already from the graph, this was a bumpy ride indeed for humanity. In fact, we had tremendous variabilities of plus minus 10 degrees Celsius. This is data from Greenland over just a decade. It could go up and down. We had a rough time. We were hunters and gatherers. We were a few million people on Earth. We had, to put it simple, a rough time. Until we leave this ice age period, this 100,000 years of deep variable ice age, and enter this extraordinarily stable interglacial phase that we learned in school to call the Holocene. This is the interglacial stage that has enabled us to develop modern civilizations as we know it. How could that be? Well, what do we do when we enter the Holocene? Well, essentially the first thing we do, just 2,000 years into the Holocene, is we do the most important invention of all. And I must excuse myself at this innovation event here at the Republica. It was not the digital revolution or the iPhone or vast computer capabilities. No, the most important invention of all time for us humans is when we invented agriculture. We started to domesticate animals and plants. We went from being hunters and gatherers to become small-scale sedentary farmers. And the trick is, and why this is so significant, is that we know today that this happened roughly at the same time on all continents on Earth, at a time when we could invent rice and maize and corn and wheat on different continents. And last time I checked, we didn't have a mobile phone to call each other and say, well, I came up with this great idea. You plant a seed and it can grow and we can domesticate animals and plants. Oh no. We know today that the reason why this occurred simultaneously across continents was simply that the rainy seasons became so stable. Temperatures came and went so stably that we knew when spring came and we knew when autumn arrived. We could simply be reassured that the investments, the risks of investing in planting seed was worth it. And off we went and established societies as we know it, differentiated technologies, enable ourselves to invent ourselves all the way to the modern societies as we know today. So the conclusion is as simple as it is dramatic. The Holocene is the only state of the planet we know for certain can support the modern world as we know it. We have lived outside of the Holocene. We can be hunters and gatherers in the caves of a glacial or completely different planet. But if we want to take an ethical responsibility for the world as we know it and our co-citizens on Earth, then the Holocene is our Garden of Eden. Insight number 2. Insight number 3 is that if we punch the planet so hard as we're now doing in Anthropocene, the question is, how does she respond? Well, when she's resilient and can buffer and really take and dampen our stress, nothing really happens. Incremental change is actually the way that rules the world. In fact, we believe so strongly in this that that's how we've developed our economic system, our governance system, just assuming that everything is predictable, linear, and incremental. That's, by the way, the only reason why we can have discount rates, for example, the assumption that things change linearly. But science shows over 30 years of advancements that it's completely the reverse, that non-linearities, tipping points, sudden surprise is part of normality. During long periods of time, we can unsustainably release greenhouse gases, cut down forests, overfish oceans, and the system just buffers and reduces impacts up to a certain point, a small incremental change, and the system can cross a tipping point and irreversibly change conditions and undermine and potentially amplify warming, undermining our abilities to the future. Now, we have so much evidence of this today. We have here summarized, for example, the tipping elements that we know have multiple stable state and that can cross tipping points. For example, permafrost, Arctic winter sea ice that can flip over from stability to instability, reinforcing warming. The forest systems and coral reef systems that can flip over from hard coral systems to soft algae system. The rainforest system, the jet stream, the fundamental systems that regulate the entire planet in this interconnected Earth system that is all dependent on stability in a Holocene state. In fact, we have even gone one step further, recognizing that these systems are so interconnected that we can today talk of tipping elements being connected in what we call cascades, where if we cross a tipping point, for example, irreversibly causing the Greenland ice sheet to start melting, irreversibly losing methane from thawing permafrost, that could bump us up one level of temperature. The latest paper that we published a year ago, the Hothouse Earth paper, that, by the way, last year led to the word of the year here in Germany, Heißzeit, was a very careful assessment where we said, if we continue burning fossil fuels up to 2 degrees Celsius warming, what is the response of the Earth system if we cross tipping elements? Our careful assessment is that that could bump us up another 0.3 to 0.4 degrees Celsius to 2.4 maximum, which could then release crossing tipping points in other systems and lead to a cascade that could take us across the threshold towards a hothouse Earth, a Heißzeit. Now, this is now summarized so well in science that we were, for the first time a year back, able to communicate to the climate negotiators in Bonn the first time, and then in Katowice, that now we know that based on this curve, which I just showed you earlier, which is this desired pathway of, perhaps you don't see it so well, this is the last 20,000 years. We leave the last ice age and we enter the Garden of Eden, the plus minus 1 degree Celsius, 12,000 years, as you see in this line here. Here you have the Paris Agreement, which is to stay well below 2 and aim for 1.5 degrees Celsius, which is actually outside of the Holocene range, which is something to remember. Here is where we're following today. We're rushing on a path that can take us to 4 degrees Celsius warming by end of this century. But here's the key message. We can now scientifically add to this the risk of crossing tipping points. And what you see here in the red to yellow columns is the scientific uncertainty, because we don't know exactly at what temperatures in the y-axis we risk pushing systems across irreversible thresholds. But look at this square here, which is the square with scientific evidence that we already in the Paris range are at risk of crossing tipping points. And look at coral reefs. The entire uncertainty range lies within the Paris range. What does this mean? Well, it means that from the knowledge we have today, we are very likely to lose all tropical coral reefs, even if we are able to stay below 2 degrees Celsius warming. So we have the first planetary victim already at the situation we are at today, because we're rushing towards a point where it's very difficult to stay well below 2 and avoid the risk of losing all tropical coral reefs. But you see that alpine glaciers, Arctic summer sea ice, and even Greenland, despite the uncertainty range here, is at risk of crossing a threshold to irreversible melting already at 2 degrees Celsius warming. To the furthest left, we have the West Antarctic ice shelf, another 6 to 7 meter sea level rise that is also at risk of crossing a tipping point, irreversibly melting at low temperatures. Now, this does not mean that the planet would fall over a kind of a disaster escarpment the day after we cross a tipping point. But what it means, and what my key message to you here today is, that what we do over the next decade is the point, very likely the point, when we determine whether or not we press the on button for a journey that would irreversibly take us towards these outcomes. That it's now we can change directions to avoid coming too close to these danger points. Because once we press the on button, the Greenland ice sheet would irreversibly melt. It would probably take 200-300 years, but it would be irreversible. We would be committing all future generation to that trajectory. A few months after the Hyzite paper, this paper came out, which in my mind really homes in the final conclusion, how important it is to recognize the need to now become stewards of the whole planet. What you see here is a timeline from the future in the year 2100 all the way back. Here's 1 million years, 3 million years, here's 60 million years back, and on the y-axis you have average temperature on Earth. Now, the drama is, and here you have the Garden of Eden, right here, and what you see in this line is that if we continue business as usual and reach 4 degrees Celsius by end of this century, we are winding back the climate clock, well behind the Holocene, but even beyond 1 million years, actually beyond 3, 5, we are winding back the clock to, as far as we know today, to the conditions on Earth as they were some 10 to 20 million years ago. That's what's happening in a blink of time, the Industrial Revolution of 200 years. So this is the drama. We are now really in the Anthropocene, fiddling with the whole system. Just a few months back, colleagues at the Potsdam Institute reinforced this even further in what I would argue almost like the most humble recognition of why we have to take care of the planet, showing that over the last 3 million years, this is 3 million years on the x-axis, here you have average temperature on Earth. This line here is 2 degrees. So with the best possible analysis and modeling we've done today, we can say that for the last 3 million years, which is called the Pleistocene era, which is the era when the planet has been configured roughly with the same continental configuration as we know it today, we have not been beyond 2 degrees. Just shows us how much it matters that we today act. So what does this mean then solution-wise? So let me just try to take this then to a new framework for the future. Now, the conclusion then becomes the following, that if we are in the Anthropocene, if we are at risk of causing tipping points, and if we depend on the Garden of Eden as a Holocene, of course, if you sum this together, the conclusion is that we need to now ask 2 questions. What are the environmental systems that regulates the state of the planet? And what can science say on defining a safe operating space for us to be able to stay in the Holocene, to avoid that the Anthropocene pushes us irreversibly away from a manageable state on Earth? That becomes the Planetary Boundary Framework. And the Planetary Boundary Framework defines the 9 systems that we as scientists have shown now quite clearly regulates the state of the planet, which is not only climate, it's also the oceans, the stratospheric ozone layer, it's land, water, nutrients, and biodiversity, chemicals, and aerosols. 9 big systems that, as far as we know, if we can keep them within the green, safe operating space you see on this graph, quantified for 7 of the 9, we have a good chance of having a good future for humanity. As you see here in yellow and red, we are actually transgressing 4 of the 9 boundaries: climate, land, nutrients, and biodiversity. So we are in a danger point. But science also is clear. The window is still open to take ourselves back, because the planet is so remarkably resilient that we still can see good abilities to actually help us buffer a journey back that is at least a manageable state for the planet. But we have some warning signs that this science is correct. One of them is the jet stream. The jet stream, which is the high latitude, high-speed wind patterns that regulates high and low pressure weather systems in the northern hemisphere, which is showing increasingly patterns of losing its harmonious configuration due to actually the rapid melt of ice in the Arctic, which releases large levels of heat and slows down this whole system, which has led to conclusions that the jet stream is increasingly becoming weird, which could explain, which we've seen in several scientific papers now, the explanations behind extreme heat waves and cold periods in Canada, the US, the Nordics, part of the northern hemisphere, depending on these weather systems. We have also increasing evidence that the ocean planetary boundary is fundamental, with a slowing down of the ocean conveyor belt that kind of transports energy through the planet, and that this slowdown of the conveyor belt is at risk of also impacting the livability in parts of the northern hemisphere, not least my own home country, Sweden, because of a slowdown in the Gulf Stream. And that this is now established in the latest science, not least led by the Potsdam Institute. So we see signals that we are actually seeing these cracks in the ability of the planet to remain stable. And what really makes me nervous is that we've always thought that the Arctic is the most sensitive system and the Antarctica is so stable, but increasingly science shows that the West Antarctic ice shelf is probably more vulnerable than we previously thought. So there are so many pieces of evidence that we really need to take care of the system. And as you know, already at 1 degree Celsius warming, we are on a pathway where even sea level rise is now, through satellite data, proving to become a point where we are at 20 centimeters sea level rise now, and we are on a journey towards at least 1 meter sea level rise by the end of the century, if we do not cross thresholds and move too fast in a direction that can take us beyond a point of manageability for large parts of coastal nations in the world. So that's the story. That's the diagnostic. Let me then spend the last 10 minutes just to say, how can we translate this into action? How can we avoid situations like this, where we move from the Holocene into unmanageable sea level rise of 10 meters plus in the world, which would put so many billions of people under really, really devastating conditions? Now, to match this challenge, together with Christiana Figueres, who's led us in the successful Paris negotiations, and her Mission 2020 about bending the global curve of emissions no later than next year to follow the scientific necessities, we presented the Global Climate Action Summit in San Francisco last year for the first time an assessment of whether it is possible to follow the IPCC 1.5 degrees Celsius report's conclusion, namely that we need to cut emissions by half by 2030 to follow a pathway that can take us towards 1.5 degrees Celsius warming. Now, that was a challenge, but it was also inspired by some really frustrating outcomes we've seen over the inability to recognize disruptive innovation, exponential change, particularly in the entrepreneurial sector. You may have seen this graph. This is kind of a classic today, with the World's International Energy Agency doing its World Energy Outlook each year on photovoltaics in the world. And what you see here is, on each flat line, their efforts of projecting what's the best possible projections on developments on solar voltaics. And you can see that each year they simply underestimate, and the black line is the actual observed installations of photovoltaics, which means that predicting nonlinear change is very difficult when you are still in an incremental linear mode, and that the world is nonlinear also on the solution side, not only on the risk side. So we took the latest evidence on solar voltaics and wind and could show that we are today on an exponential journey. What you see here is from 2000 to 2030. The first 15 years here is actually observations, and on the y-axis you have installation of electricity globally and its percentage in the global electricity mix at the world scale. Now, this looks very limited and insignificant, which is correct. It's from 0.8% to 2.8% in 15 years. But it follows an exponential path. It actually doubles every 4.5 years. Now, for those of you who remember your high school mathematics, or perhaps are involved in exponentials today, as I'm sure many of you are, know that if you follow a path like this, it may appear very limited in the beginning, but if you project this to the future, and in this line here, we took a conservative assessment of also what's realistic, we see that this is an exponential curve that would actually, by 2030, take us to a point where 50% of electricity in the world would come from solar and wind. Business as usual, even in a conservative assessment. Now, same goes for other parameters which actually surprised even us. To the left here, you have the number of countries in the world that by 2010 and projected to 2020 have decoupled economic growth from greenhouse gas emissions. 2010 it was 49 countries. 2020 is projected to be 53 countries. And these are not just the Nordics of the world, these are representing 40% of global emissions. Now, 50 countries is quite interesting because, as you know better than I do, when you're introducing innovation on a market, the valley of death is crossed when you reach something like a 15% penetration of the market and can really start scaling your new ideas. Well, what if the same goes for alliances of nations changing? 50 countries happens to be roughly 25% of the countries in the world. We have roughly 196 countries in the world. Now, what if this large enough minority starts tipping over the majority towards an inevitable journey towards decarbonization? And we can see evidence of similar types of change on the right-hand side here, which is the number of countries that have adopted a price on carbon. We fight over this all the time. We see difficulties in adopting a global price on carbon. There's so much scientific support, and my dear colleague, co-director of the Potsdam Institute, Professor Ottmar Edenhofer, shows clearly that a price on carbon is an absolute prerequisite to be able to scale and exponentially decarbonize the world's energy system. But it's so difficult to get political support. But can you imagine, we have 50 countries today that have adopted a price on carbon. Again, we're approaching this 25% point of a large enough minority, showing that a price on carbon actually makes sense also for sustainable economic development. We went through sector by sector, showing that with current technologies, we can actually cut emissions by half by 2030 with practices that we have today. It requires policies and it requires investments, but it can be done. Now the question is, are we moving in the right direction? Unfortunately, the answer is really the punch in the stomach. And I think we need that as a closing remark here. So this is a fantastic paper from dear colleagues at Leeds University in the UK, for the first time taking the planetary boundary framework and checking how countries are doing. And what you see here on the x-axis is the number of planetary boundaries that are transgressed. So the further to the right, the worse we're doing. The more of the boundaries we are moving out of the safe operating space. And on the y-axis here, you have on the list different human development indexes showing aspirational goals that we all value so much. Longevity, Human Development Index, economic growth, kids in school, health indicators. So the further up you are, the better we are at delivering on the Sustainable Development Goals. So where do we want to be? Well, we want to be up in this left-hand corner, where we are in the safe operating space, achieving good social and economic development. I cannot see one country up there. The dots here are the countries in the world. The rich countries in the world are in this upper right-hand corner. That's where we have Germany. That's where we have Sweden. So today, unfortunately, we're still in a mode where we're delivering on social and economic human well-being at the expense of the planet. She is paying. And we need to transition rapidly up to this equitable, sustainable left-hand corner where we see no countries today. So how can we do that? Well, I think the mind shift is required, that humanity's future is at stake, and we now need to redefine sustainable development. I would redefine sustainable development for the first time, linking people and planet. We are no longer in incremental mode. This is the transformative moment. We need to now exponentially and in a disruptive way move along a path that can cut emissions by half every decade. That's the carbon law, inspired by Moore's law, by the way. And I would define sustainable development in the 21st century, deep into the Anthropocene, as prosperity and equity within planetary boundaries. We need equity and prosperity for people on a stable planet. And perhaps as a closing remark, what could help is something that helps me, at least personally, which is to recognize that up until recently, we were still a relatively small world on a big planet. This is why I would not accuse climate skeptics too much. I wouldn't accuse too much conventional economists and all those who live still in this belief that we can just continue linearly to exploit here and waste there. They still live in this old paradigm that the planet is so big. It can cope, it can simply deal with our unsustainable pressures and simply deliver free subsidy to our economic development. But no, science is now clear. We have quite recently flipped over, and today we are the big world on a small planet. The planet is very small, and we are the big world. And we've saturated the whole system, and we have to take care of the whole system. And the Sustainable Development Goals, the framework that was adopted by the General Assembly in 2015, is the first framework, the only framework we have to succeed in that direction. The 17 aspirational goals that for the first time integrates people and planet. The problems, dear friends, is that this aspiring agenda is still handled largely, I would call it like a Swedish smorgasbord, basically. Countries just pick their little favorites among these 17 goals. I would say that today there's a scientific support to reconfigure these 17 goals into what I call the wedding cake. The wedding cake is that we have 4 goals that are non-negotiable, that are the planetary boundaries. Goal 6 for water, goal 13, 14, 15 for oceans, biodiversity and climate. They are the planet. They are the guardrails. They provide the non-negotiable scientific platform for our ability to have aspirational goals for society, to be disruptive, to be innovative, to be equitable, to really have a good future for humanity within the safe operating space for humanity. So my scientific message to leave you with is simply this one. Put the Sustainable Development Goals inside the planetary boundaries, and I think we have a chance to transform into that window that is still open, but it's only open for a limited time. So it's wonderful to have this opportunity to exchange with you and to kind of contribute towards a dialogue and a momentum towards a sustainable future for humanity on Earth. Thank you so much.
And right now we have a little time for questions. If you have any questions, raise your hand. Yeah, I come to you.
Hi, thank you. That was a really great talk. I'm a social entrepreneur. We're producing solar generators, 200 watt, 12 volt, from actually panels who normally would get discarded. And this for rural electrification, for example. You just said that there's a lack of acknowledging disruptive entrepreneurial ideas, and I feel that actually quite a bit, because people are like, oh yeah, that's a great idea, but does that actually really bring enough profit? Do you have a tip for an entrepreneur who is actually really aligned with the Sustainable Development Goals, how to reach like the next level. How can we be heard by the people who are always saying the private sector has to do something? And I'm like, I'm doing something, but sort of no one is listening.
Well, actually, I think that many in the audience here are much better placed to answer that question. I mean, I would, of course, encourage you to just push your passion for the ideas you have. But I think that, and probably many of you are in the room as well, I mean, that I get knocks on my door all the time with, private equity fund managers or philanthropists and different actors that are now trying to put really their mouth behind the action on investing into new ventures. And I think that the challenge today is to match good ideas as yours with investment capital. And I think we see increasingly that there's a mismatch also in how to connect the investment, the money, with the ideas. And I think that's why these kind of platforms like Republica are absolutely fundamental. But definitely, I think there's also something emerging increasingly, which is partnerships between science, policy, and business that can also unleash some of these new ventures. Because in the past, there was always like science policy and then policy dictating business. But now increasingly, I think we see partnerships between the three. And I think that can also, potentially help in opening doors for new ideas as well. But it's, of course, a challenge. I see that.
Are there any more questions?
Hi, thank you very much. I feel after so many years of bad news, I have like a deep climate change depression. And I just 10 years just feels so short. Can you just make me be a little bit less climate change depressed?
Yeah. Well, say two answers to that. The first one is that I respect climate depression. I would, though, quite strongly try to urge you not to be depressed. I would rather urge you to be angry, to be honest. I think it's and I really mean it. I mean, it's time for us, I think, to use the fear and the sense of of emotional reaction and depression into reaction, and I would strongly encourage that. Actually, that's I respect it, but I think we now need more kind of disruptive behavior as well. That's one. Secondly, I am personally convinced that putting all the cards on the table is absolutely necessary. I mean, however uncomfortable it is, we in the scientific community, I mean, to be honest, if there's a red thread in science, it is that we have underpredicted, we have actually underestimated the pace of change. That's a self-criticism of science. And it is important to recognize that now science is stepping out of its comfort zone, and is because it's becoming so nervous of all the evidence we're seeing. So I would say, even from that perspective, I'd rather, if the house is burning, we'd rather report that it is burning than kind of tend to always have this tendency of trying to be too overly careful in the way we present the data. And quite frankly, the reason why there is reason to be deeply concerned today is that when you lay the whole puzzle on the table, which is not only about emission of greenhouse gases, not only temperature rise, but it's also what is happening with ecosystems and biodiversity, that's when you get the whole picture. So there's something valuable, I think, with putting the cards on the table. The final point, though, which I really give you full credit for, is that I think we as scientists should not be allowed to just give the negatives. We should also be forced always to say, so what? So what do we do then? And I realized I spent very much time on the negatives and not so much time on the solutions here. But I think I hope at least I gave a signal also that we start seeing there's turbulence on the risk side, but there's also turbulence on the solution side. And that's why this is a very exciting moment, actually, because I've never experienced so much momentum and willingness to move. And I've never seen so many solutions and so much energy in the whole climate agenda, looking 20 years, 30 years back. So in that sense, I think we have to match the depressive side with the solution side. But I really thank your testimony of what very many feel. I can also feel that sometimes.
Question down the hall, there.
Thank you for that on that very last point. I mean, I've worked in clean energy for 10 years, specifically storage and system integration, and it was very heartening to see your prediction of how wind and solar would go up. But also from my experience in working in this space, I mean, for the last 10 years, specifically in Germany, we've had all the technology. Politicians always say we don't have the technology. That's not true. We have the technology. And a lot of it is digital, by the way. But we're not implementing it. Yeah? And we're not doing it, even though a lot of it has happened, I agree, in the last 10 years. So how do we get the politicians to really start implementing the solutions that are already there and that would even create cheaper energy, but they are not being implemented? And just one example, we trade electricity in 15-minute intervals when each of us has this in their pocket, and we could be directly using solar energy directly, but politicians are not willing to do that.
No, I think, well, you're putting your finger on what is the big challenge we're facing, which is that we have all the evidence we need, that we're facing very big risks. We have the solutions, and still we're not moving at scale. And that a large part of that is that we don't have the political leadership to unleash, to provide the incentives that can take us in the right direction. So why is that, and why aren't we moving? I think is the kind of the holy grail of how we can solve this challenge. And I think well, to begin with, unfortunately for us, we are at a point where we have a relatively speaking weak political leadership in the world. And I think that's very unfortunate. We don't have, I mean, again, I would look back at Germany perhaps being the exception among all countries in the world. I mean, here you have Chancellor Angela Merkel is a strong leader. I mean, she's struggling with domestic affairs here, but you've just gone through the Coal Commission. You have discussions on a climate law. I think there's opportunity here. But if you look at the European Union at large today, it is not showing the leadership we need to match exactly your point. We don't see it in the US, we don't see it in China, despite the fact that they have the opportunity for it. So I think the only chance we have today is that we start seeing more civil movement together with business, that kind of entrepreneurs and civil society really showing the direction that let's say societies want to move. And why this can work, I think, is that the political leadership is today, you could turn around the weakness in leadership into something positive, meaning that they're quite reactive and therefore also following opinions very carefully. They're the kind of reactive political leadership rather than the kind of political leadership that you would normally expect as leading properly. So in that sense, I think the pressure points are really important. So for example, I think, again, I'm coming back to the Fridays for Climate, the whole youth movement. I think, as you may know, that has been matched by the Science for the Future, which is quite extraordinary, actually, that over 20,000 German scientists signed on a letter giving its full scientific support for the youth movement, which is unprecedented. I mean, that scientists would actually lend its support in that sense. Now, will that be enough? It's a big question because of the limited time we have. But I think we have to play all the cards at this point, and I think we simply need to give constructive pressure on the political system.
We have a question here from the front row.
So, how many of you have come by plane? So, the idea is, my absolute conviction, I'm absolutely convinced that there is no reduction of the climate change without sacrifice of some comfort. So, here are many people who cheer up for Fridays for Future and Greta and are really concerned about the climate, but nobody wants to sacrifice anything.
Yeah. No, so here I'll kind of, it's a very important issue you bring up here, and let me kind of give a little bit of a deeper reflection on that, actually, which is, may come across as not automatically the most comfortable conclusion. I agree with you, and there is big lifestyle changes required for us to succeed in a transformation to a sustainable future. At the same time, one has to recognize that we have been struggling. I mean, I've been part of the environmental movement, as perhaps many of you, for the last 30 years, and the environmental movement have been struggling since Rachel Carson and the Silent Spring in 1962, and largely failing. And it has failed to a large extent because the environmental movement has been pushing so hard on environmental values in such a good way, but it has therefore also reached only a minority of the citizens in any given society. Because as long as the story has always been that it's about protecting nature, we humans are bad, and the only solution is to sacrifice. The only solution is to give up and to move away from what is perceived, at least, wrongly in many cases, but perceived at least, to be, let's say, a modern way of life. That has a tendency in countries like Germany and Sweden, which I would argue are at the forefront of success in the environmental movement. It kind of hits a ceiling at 15% of the population. You don't reach outside of the educated, quite well aware and reasonably income level part of society. But now we are at a situation where the entire societies have to become sustainable. We have to have 100% decarbonization, and we have to have 100% sustainable societies across the whole value chains and in every sector in society. So how can you get the world to transport itself in a sustainable way? I think that the solution is therefore not to go out and simply say, stop flying. I mean, that would be like the only message. Because I think that just creates a deeper rift between the aware environmental movement and everyone who just says, oh no, I'm not gonna sacrifice that, and therefore I rather put my head in the sand and create my own little fake news story of something that will somehow make this not happen. So therefore I think the solution for us to succeed, to really have even the indifferent majority to surf along with us, is to show that sustainability is the entry point for a better life, that we can achieve better quality of life, not just by consuming and unnecessarily flying when we don't need to. Yeah, of course, I see. All forms of excessive consumption, you're right. And we know, by the way, as you've seen the graph certainly, that increased consumption just makes human well-being better up to a certain point. After that, we don't get happier, and we certainly don't get healthier, and we just go kind of gradually downhill. So we have to start really, I think, changing the story to show that sustainability is to be cool. It is the healthy, it is the better, it is the more attractive pathway, it's the more modern pathway, it's kind of the Tesla future. And that is it's a different tack of how to take this story along. And I agree with you that, at the early stages, it must mean changing also behavior in the way, in how much we use cars and how much we consume and how much we fly. But I think we would help the world if we start telling the story of how attractive sustainability is, not a sacrifice story. And that's a change. And I think coming back to the question of the fellow here earlier on solar voltaics, the good news is, of course, that we're starting to see that we can accomplish that. That we have, I don't know if you know this, but I mean, Harley-Davidson in August 2019 is going to go electric. I mean, isn't that kind of just the biggest shock of the world? I mean, here you have the die-hard, oil-loving, petrol, noise, boom, running motorcyclist, and Harley-Davidson is going electric. It's launching LiveWire. It will continue to produce, of course, also combustion engine-based, but why is it doing this? It's doing this because it sees that a whole new generation of young people is not so attractive of these big combustion, oil-run, gasoline-type transport. It is cooler and more advanced to go electric and just into the future. So there's something happening here which I think has to do with the new story, and I think you're the best ones to tell it, by the way.
So I think we have time for, thank you very much, for one very small question. Is it a short one? Okay, give it a try.
Yeah. I wanted to ask you, because you were talking about Fridays for Futures earlier on, what we as the younger generation should tell our parents or teachers when they say, why don't you just go out there and demonstrate for it out of school? Because we were doing it in school time. For me, I know why, because otherwise the people or the politicians wouldn't listen. But what do I have to tell my parents so they support me in doing it? Do you have the answer for that?
Yeah, so your question is, should I on stage encourage you not to go to school? So actually my answer is quite simple. You've done your homework. It's time for the adults to do their homework. And I would say that you've done it so well that if that costs you a Friday afternoon every second week, that's fine. You'll be so well prepared for the future that that will bypass the elder generation in terms of intellectual accomplishments. I'm all for what you're doing, and we need more of it. Thank you very much for the efforts.
Thank you very much.
Yeah. Thank you.
TM.